I'd like to go through another technique for solving for images and mirrors, which is to graph or draw rays of light. We've done some examples now where an algebraic set of expressions was used to derive where is the image and how big will it be and whether the image is inverted or not. But we can also develop some intuition if those calculations actually match up with some of the constructions we had at the very beginning of our discussion of optics about how light reflects off of mirrors. So there's a rather simple technique here to draw pictures of light reflecting off of mirrors and draw in particular 4 rays of light that will basically solve the problem for you as long as you're a good artist and can draw things to scale. So remember that if you have an object sitting over here in front of a mirror, so this is my mirror, the object is emitting light in all different directions because sunlight might be coming in or a light source is coming in, and this object is reflecting light in all different directions. We could draw light coming in every possible direction off the tip of that little arrow, but we're only going to draw 4 particular light rays because they will help us solve this problem relatively easily. The first light ray is one that comes parallel to the center axis of this mirror. So remember, we often draw a line that goes right through the center of curvature of the mirror and into the mirror, and we put our object right on that center axis. So such a light ray labeled number 1, what does it do? When it comes into a curved mirror, it's now parallel to the center axis, and by the definition of what we call a focal length, when this light ray comes off, we should draw it such that it goes right through the focal point. So it keeps on going forever and ever and ever, but we know that it has to draw through that it has to go right through that little focal point. So it might be useful to take a little ruler and connect this light ray that we drew into the mirror right to there and then draw a line because it went right through the focal point. The second light ray is going to go off in some direction, and it's actually going to hit go right through the focal point. So notice my number 2 comes down and goes right through that point F, keeps on going and hits the mirror. And remember, the focal point is defined in such a way that if an object was located at the focal point and emitting light in all different directions, then the light coming off the mirror would be reflected parallel to the axis of the mirror. So notice that this light ray number 2 comes back and is being transported exactly parallel to that axis. Right away we can see something because light ray number 1 and light ray number 2 crossed at a certain point. There's a couple other light rays that are convenient to draw here. Light ray number 3, when it comes down and goes through the center of curvature of the mirror, because the center of curvature always intersects the mirror at a right angle, that's a perpendicular to the mirror, and we know that the reflected ray comes right back in the same direction because that's like standing in front of a flat mirror. So the light ray goes right back in the same direction, and that's what I've drawn as number 3 comes down into the mirror and comes right back out. Number 4 hits the center axis of the mirror, so this point V, which is sometimes called the vertex of the mirror. And such a light ray is somewhat easy to draw its reflection because we can see what the angle off of the perpendicular is, and we just draw it reflected on the other side by the same amount. And it comes down here. Number 4 is right down here, coming in at the same angle as it was coming in. Notice that all 4 of those light rays intersect at one point, and that one point indicates what's the image location for the tip of that arrow. And since the base of the arrow will still be on the center axis, the image of the base of the arrow will still be on the center axis, that means that the little image of the arrow is upside down, so we know that this is an inverted image. In terms of magnification, by saying it's inverted, we know the magnification is negative. And notice that the image is over on this side of the mirror, the so-called real side of the mirror, so I should be a positive number. And also notice that the arrow seems to be shrunk compared to real life, and that means that magnification in absolute value will be a number less than 1. So it's a image that's smaller than the original size of the object. So we've learned some important things about this, and we've just done it by graphing some rays or drawing some rays, and that should more or less jive later on with what we find when we actually do some algebra. A similar example of this can be done with a convex mirror. We can draw an object out here in front of a curved mirror. It points the other way. The center of curvature is over this way. Light ray number 1 is again the kind of light ray that comes in parallel to the mirror, and it should always reflect back in such a way that it appears to go through the focal point. Well, since the focal point is over on the virtual side of the mirror, light never actually goes to the focal point, but it appears to come from the focal point. So if the focal point is right there, we draw a straight line up to a point where it hits that point on the mirror where the light's reflecting and keeps on going out. Now we know where reflected light ray number 1 is going to go. Number 2 is a light ray that's heading in toward the focal point, and notice I've drawn with my, imagine taking a ruler and trying to connect the tip of the arrow down to where the focal point is. The light never reaches that point, it hits the mirror right there, and so I have to stop the light ray and then turn it back, and it's going to leave the mirror parallel to the center axis of the mirror. So notice that it's parallel. Light ray number 3 is one that goes toward the center of curvature, and of course it never reaches the center of curvature because the center of curvature is on the virtual side of the mirror, and it should leave the mirror in exactly the same direction. So it comes in and then goes back out exactly along the same line. Light ray number 4 hits the center axis of the mirror, or at this location V, and it should reflect exactly the opposite side by the same amount. Of course, those light rays never meet anywhere because they're all diverging off in different directions, but they appear to meet, and if I draw little dotted lines to indicate where the light rays appear to come from, they all meet right there, and I've drawn a little arrow to represent what the image of the mirror might look like. Notice that that arrow is also smaller than the original object, so this is going to be an object that's demagnified. In this case, the arrow is pointing upright, so it's not an inverted image, we call it an upright image. And notice that the image is over on the virtual side of the mirror. It's over to the right-hand side of the mirror, so the image distance will be a negative number because it's a virtual image.